Today we are going to discuss the questions, the past paper questions from the structural isomerism. Okay, so let's start this. Number one, how many isomeric esters have the molecular formula C4H8O2? I think we did it last time. We have to draw the isomeric esters with the formula C4. मैं आपको रिमाइंड करा देता हूं मैंने एस्टर्स के आइसोमर्स के लिए आपको बताया फर्स्ट यू मेक द फंक्शनल ग्रुप ऑफ एस्टर okay then with the oxygen you have to attach all the carbon in the first go so as there are 4 carbon in total so I have attached them like this okay this is the first ester and in order to make chain isomer we have to short the carbon chain. In ester, I always tell you one thing, there is a chain after oxygen and there is a chain before oxygen. So before oxygen, so there is no chain actually. There is one carbon in the chain, but after oxygen, there is a chain which can be made into a chain isomer. So let's make a chain isomer before that. So it would be 1, 2 carbon, and the third one as a branch here. Okay, so this is the chain isomer for this. Okay, now let's make position isomers. In esters, we don't have to make the position isomers of all chain isomers one by one. We just have to take one of them, the first one, and keep changing the number of carbons to the back side. Okay, so if I take 1 carbon on this side, now after oxygen, there are 2 carbon. I mean 2 carbon from alcohol and 2 carbon from carboxylic acid. So the first one was propyl methanoate. This is what? Ethyl ethanoate. And another one is like this. This one. Here. Yes. So, but this carbon now can't go back. The last carbon that is attached with oxygen, you know, we cannot change the position of this. So how many isomers in total? 1, 2, 3, 4. Which one?
C there on top of the main carbon, central carbon.
Let me give you the numbers just for the sake of identification. Now can you?
So on the second one, can you put the C on top of the main?
It doesn't make difference.
No, the right one. The other one is the other.
Here? Yeah, that'll make the same this one. I understood your point. Now it's a still chain, but the chain gone up. So still 3 carbon in the chain. It's the same thing like this. I told you when you cannot put branch on the terminal carbon, then it'll be the part of the chain. Walaikum assalam. We are discussing the past paper questions from structural isomers. Okay, the one which we did last time. Okay, so answer is 4 for this, Pacho. Okay, this question is quite tricky. Number 6. Please look at question number 6. Pentanol has 4 structural isomers that are primary alcohols. So in this type of question, they combine actually the isomerism with another concept that is primary alcohols. So he's asking us that pentanol, 5 carbon alcohol, is 4 structural isomers which are primary alcohol, right? So out of these primary alcohols which contain the chiral carbon. Okay, now forget the chiral carbon at this moment. If I change the question and I ask you to only draw all 4 structural isomers of pentanol, which are primary alcohol. So I've changed the question. I'm asking you, listen to the question. I'm asking you to draw.
Primary alcohol.
Yes. Primary, secondary, tertiary, we did now. In alcohols and haloalkanes.
Yeah.
Should I remind you again? I think you were not there. I told you, if this is the carbon chain and you attach OH here, this is known as alpha carbon, the carbon which is carrying the functional group. You see there are 2 hydrogens with alpha carbon, or you see that there is a 1 alkyl group with alpha carbon. So you call it primary. But in the same thing, if I take the OH and put it on the center, now this alpha carbon has how many carbon attached? 2, and there is 1 hydrogen left, you call it secondary. And then if I say 3 alkyl groups, no hydrogen, That's a tertiary. You got it? The other way around is how I can remember it or memorize it. If the OH is attached with terminal carbon, it's a primary. If it is a terminal carbon, it's a primary. And if it is at the center,
then it's secondary if it's with all carbons attached.
yes.
And one OH is.
Yes. So if the center and then same carbon is also having branch on its top, then it would be tertiary. Okay. Now come to the point here. Now is asking us to draw all structural isomers which are primary. Now I would suggest you draw the structural isomers as I told you to do that, as I taught you to do that for C5H11OH. Now listen everyone. First put all 5 carbon in a chain. 1, 2, 3, 4, 5 and then OH. Look at this. How many carbon atoms? 5. OH is at the terminal carbon. Now 1, 2, 3, 4 and then OH here.
And then OH, C here.
And then another one, 1, 2, 3 and 2 carbon in the branch. Now these are the chain isomers. Can I make the position isomers? I cannot make the position isomers. Why? He restricted me. Because position isomers I have to change the position of OH. And if I change the position of OH, what happens? It would not be a primary alcohol anymore.
So we can make one more. C there. C.
Yeah. In this case, we can change, yes, position of branch. Instead of putting at carbon number 2, I just shifted its position towards this side. This is what you said?
Yes. And then now we can also do that one. We say 1 and 2. We keep change the position of 1 carbon there.
That one?
Yeah.
No, we cannot. If you put I told you a while ago, you cannot put the branch on the terminal carbons. So there is a terminal carbon next to the carbon which is having. So how many isomers we have then? How many isomers? 1, 2, 3, 4. Okay, so the 4 structural isomers of pentanol which contain which are primary alcohols, right? So this is how you have to draw it. Is it clear? Okay, next.
So the answer 4.
No, but I changed the questioner, so you would not have any option inside. Okay, can you draw how many isomers with formula C5H10 have structure that involve the pi bonds? Pi bond is the double bond. So he's asking us to draw all structural isomers for C5. Can you please do it? Give it a shot. Please draw all possible structural isomers by C5H10 which contain pi bond. It means you cannot make cycloalkane.
Okay.
Okay, otherwise there is one isomer with cycloalkane, which does not have a pi bond. Okay. We're doing the past questions on structural isomers.
So C.
Six D. Like this. Here, that's and then you move the wedge here, that's 3, 2 here. So 1, 3. Okay, so then now there's 2 here, 2 plus 2, 4, and then 5 and 6. Wait one second, I think I'm this one here. Yeah, we do the 1, 2, 2, what is the paper? Sixth one, remember the other chain. Maybe we can put this. What was the last one? We can change this chain to this. Right. You know the normal chain. There's six. There's six. Look, we can change this chain. You see the C is one on the second card. You can go to the third card. So that's six.
That is this.
Okay, here we go. 1, 2, 3, 4, 5. This is one in. 1, 2, 3, 4. Here is the branch. You can't make it shorter than this. Then let's change the position. Pend 1 in to pend 2 in. And then in this case, 1, 2, 3, 4. But 1 in to but 2 in. Again, 1, 2, 3, 4. Here it is. So 1, 2, 3, 4, 5. Where is the sixth one? Huh? This is pent 1 in. This is pent 2 in. 2-methyl but 1 in. 2-methyl but 2 in. And 3-methyl but 1 in. The last one is 3-methyl but 1 in. This is 2-methyl but 2 in. This is 2-methyl but 1 in. 5 isomers of C5H10 that contains pi bond. Okay? Okay, compound 2-methyl propene C4H8 is an isomer used in the production of synthetic rubber. In addition to 2-methyl propene, the one shown here, there are X other isomers of C4H8, structural or otherwise. Otherwise, I'm going to cross. So only you have to draw the structural, right? So in other words, he's asking you to draw C4H8 is an alkene. Draw all possible structural isomers, and once you will draw all possible structural isomers, one of them will be 2-methyl propene. Then subtract this and see how many numbers you are left behind. Do it. Please draw C4H8. C4H8. I'm just giving you a hint. Draw all possible structures of C4H8, and then you will find one of them, this 2-methyl propene. Okay? Then subtract that number, and rest of the will be your answer.
We are like this. The chiral means the chiral.
No, just forget about the chiral. Just forget about the chiral. This is the one which we are doing right now.
You know, we don't go to say 4 I. But I think it's
4.
Yeah. Sir,
Okay, this is C4H8. You have to draw all isomers. Structural one. This is the first one, butane. Then 1, 2, 3, C, 2-methyl propene, the one which is showing here as well. This is 2-methyl propene. So 1, 2, 3, 4. Here it is. Pent 1 in, but 1 in, and but 2 in. Is that all? So total number is 3. 3 minus 1. If it would have asked you one more, you can add, and that is if you take this one. What is this? Cyclobutane, because he has not restricted us with chain and position. Okay.
So minus 3. So 4, okay. So
This one you subtract, so total number is 4, so 3 is the answer.
you said it's because you made the item was strong. You're so bad. We're failing. I'm failing, guys.
Here it is, two structural isomers for C2H4Br2. C2H4Br2. There's a double bond, G. I can give you a hint, there is a double bond.
Yes.
Double bond. All structural isomers.
But how would they don't want to make a big trouble? Okay, then this is one. Okay, no, no. Oh, that's, I think that's right. Yeah. Double coherent bond. Two dashes. This one.
Done?
So I think double coherent bond and century. Yeah, it's meant once. Check out. You don't know.
Okay, let me draw it. There is a double bond. There is a high, sorry, there's no double bond. My apologies. So if you look at this, hydrogen, 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 and this is Br and this is Br. This is 1,2-dibromoethane. And what could be the other isomer? Chain to nahi ban sakte na? Yes. Could be what? Yes. 1,1-dibromoethane. So 1,2-dibromoethane and 1,1-dibromoethane.
So I know what I said.
Yeah, sorry.
So I knew that maybe the other was it.
So can you please draw the structural isomers for these compounds? C3H6Br. This is C3. Please draw the structural isomers for these compounds. Number one, I'm going to draw. This is Br. This is I. And how many hydrogens? 6. So 1, 2, 3, 4, 5, 6. There's a one isomer for this. Can you draw the other isomer for this? How? By changing the
Position of I.
position of I. So could be what? This one. Is there anyone possible?
Yeah, this we can make more sense.
The chain, the position isomer? No chain isomerism in this. Okay.
Can we draw a double one?
No, because this formula we have to meet now. This formula. Okay.
And then
Okay, now come to this one. In this case, you have to make a double bond.
P in the middle. PR in the middle.
1, 2, 3. Here is the Br, and here is the I. So how many? 1, 2, 3, 4. What about this?
I don't have second carbon. Okay.
Yeah, that we already made it. No? Yeah, that's another. Sorry. Here it is.
That's 5.
5C.
8%.
Okay, now what about this C3H4Br? Now you can understand there'll be a double bond. Otherwise, four hydrogens can't make complete the carbon's four bonds. So one, two, double bond, and then this one. Okay, now here is the Br, here is the I, and then this one.
The function group on both is.
Yeah, same. We move the position. Here is the Br, here is the I, and there is a possibility that you swap their positions. This is the Br, this is the I. Okay? No, we cannot, because that will overshoot the number of carbons, number of bonds in the carbon. Okay, but what we can do, we can change their positions with the double bond. For example, here is the Br,
No, you can do 5 then.
and here is the I. Okay, now again you can change the position.
No.
This is I, and this is Br. That remains the same.
So you can see you. So 5 7. I
Is it 5?
Is this possible? Yeah. So 1, 2, 3, 4, 5.
Yeah, 5 again, because like you can't change the position of the double bond, something the same.
Yeah, if you switch the position of double bond, so you'll start getting the same things which we have got here, the last two. Okay?
What about Br and I on the same carbon?
We can't put it in the same carbon. Oh yeah, one more possible. Yeah, here you go. We can put it on the terminal carbon. Na? Good check. Good check, man. Here it is. We can put it at the terminal carbons.
Then why is it one more from the other one?
How?
So that one
The center one cannot have both together. Na? Because center one has only one bond available. Because carbon cannot have more than 4 bonds.
so it's 6 and 5.
Yes. Okay, what about this C3H6I2? C3H6I2. Again, there are all hydrogens. So iodine on the 2 carbons, 1, and then iodine here, and iodine here. Then 1, 2, 3, I think here, and here, and one more, where the both iodine are at the center. So kitne ho gaye? 1, 2, 3, 4. Where is the 5th one? Yeah, that's all.
I want to do another guys.
C3H4Br2.
C3H4 Br2 is
Again, there are 2 Br here, 1 Br here, and 1 Br here, and then again 1 Br here and 1 Br here, and the last one where the both Br at the terminal carbon on this terminal. Okay,
wait, why is it
so 1, 2, 3, 4.
so why is it 6 like last time?
No, because there is Br is the same, na? Last time there were Br and I. There was I. Do you get it?
Okay, you get those two because they're high.
Are you getting it? I'm doing it quickly because I believe now you have achieved that pro level or pro max level. Pro max, I believe. Okay, next. Should I move on?
Yes, sir.
Click so long to make your questions there.
Okay, now this is the last question before we move on. Now look at this question. Read it carefully, bacho. Kind of maths involved. What is the total number of different chloroethanes with the formula C2H6 minus NClN? Can you write this formula with you? C2H6 minus NClN. Yes, I did. Ashna. Otherwise, I'm going to share right now. Okay, please, can you, okay, now, and he's asking us where N is 1 to 4. Now, let me first explain the question to you. Question seems a bit tricky in the reading. वो कह रहे हैं कि आपको N की value क्या डालनी है? 1 to 4. And then you have to look, for example, if I put the value of N1, then what will be the formula?
C2H5 Cl1.
Cl1. If I put the value of N2,
C2H3
no, 2.
Cl2.
Cl. If I put the value of N3,
C2H3 Cl3.
and if I put the value of N4,
CH2 Cl4.
okay, now you draw the isomers. All of them. How many of them possible?
This will all write in the exam set.
Sorry?
इससे बेहतर है तो कई बार है
And this is for one MCQ. But doing practice here, now you have made a sense ना. अब exam में जब आप जाओगे, you don't need to do that much hard work. देखते ही आप देखो ना, देखते ही आपको एक अंदाजा हो जाता है कि this number should be close to.
Thank you. Yeah, please repetitive questions, okay? You the question.
Like, I just want this, we don't have many questions, but yes. Yeah, but this one is easy, there's no.
Carbon soup, no,
See,
double bond.
it's equal to 6 is an alkane, it doesn't have that one. Okay, so one, that's good. CM, two isomers. Three isomers. C, trust. So four is so seven total right now. Now we do the last one.
One over option. So go to 9.
So this is the same thing as this. This and this are the same. What you make it, right, so that means this.
ग्रुप में आपको डाला होगा 500 बच्चे उसका वर्क करें कोचिंग करके ना उसको वो उधर ही खोलेंगे ना एक परसेंटेज बता के दे Okay, first one C2H5 Cl1.
So there's two. It's 1, 2, 2. 1, 2, 2. 1 plus 2 plus 5, 7.
Chloromethane has one isomer. C2H4Cl2 has two isomers. Two isomers mean 1,1 dichloro and 1,2 dichloro. Similarly, this one has two isomers. One is 1,1,1 trichloro and the other one is 1,1,2 trichloro. Okay, and the last one 4 wala jo hai, this is 1, 1, 1 and 2 tetrachloro, and there is one with 1, 1 and 2 tetrachloro.
That's 2, so 7.
So 2 this,
7.
2 for this, 2 for this. No. Yes, 2, 2, 2 and 1. So total number is 7. Total number is 7. Okay? Yeah, 7 is the total number. Do you get it?
Yes, sir.
Okay, here it is. There are 3 more alcohols with the molecule formula C4H10O. That are the structural isomers of butane 1-ol. Complete the table below by drawing the displayed formula of each of these 3 compounds. For each isomer, state whether it's a primary, secondary or tertiary alcohol. First, you have to draw the isomers and then you have to state whether it is a primary, secondary or tertiary. Okay, please do it. So he's asking for C4H10OK isomers. We have learned how to make C4H10OK isomers, right? 1, 2, 3, 4 OH. ये chain वो बना चुका है. We have done before. First, you make chain isomer, then position isomers. Okay?
So just put it on the second column.
Yeah, you just have to make 3 more. Okay? Not all of them.
So secondary is 4.
Yeah, if you make the position isomer for this butane 1-ol, yes, it will be secondary.
Yeah, that's okay. Then C3.
The secondary
The OH position just turns from terminal to the next.
So this is the primary also. Propane 1-ol, propane 1-ol. 2-methyl propane 1-ol, right? It's primary.
No, it's not.
Yes, this is a methyl carbon. If I put the OH here,
Oh, yeah.
then it's
ये मेरे से ना वो इससे ना ढूंढ के ना वो जो बाद में ऐड हुआ है पहले काम आया हुआ है उसको दोबारा रीसेंड कर लेना अपने उसी ग्रुप में.
That's different.
Yeah, I know.
That's secondary.
How is that secondary?
Because
3 alkyl, 1 hydrogen.
Excuse me.
no, is that tertiary? I think it's actually. Or is it different?
Tertiary के अंदर there is no hydrogen.
1, 2, 3, 4. So let's make a chain isomer. Sorry, here is the carbon and here is the OH.
Yes, secondary is
That's not tertiary.
Here it is. You have to draw the displayed formula. It is 2-methyl propane 1-ol,
yes.
and it's a still primary.
And then it's
Tertiary.
tertiary.
Yes, if I switch the position of this OH to the center, yes, it's gonna be a tertiary.
Yes, see.
This is what tertiary. Although we can make more, but he's asking us for 3 only. Did you get it? No? When the, yes, 3 alkyl groups attached with this. Okay? If you could have made, I told you how to make it. Look, 1, 2, 3, 4, and then OH. Look, 1, 2, 3. And then here, then what else? Then change the position 1, 2, 3, 4 here, or then change the position. Here is the carbon and here is the OH. So total number is 4. Out of those 3, 1 was already shown, so 3 more we have drawn. Okay, the next is how many isomeric aldehyde have the formula C5H10O? Please give it a shot. H10O. Only aldehydes. Yes. How many isomeric alcohols with the aldehydes have the formula C5H10O?
It can only be at the end, and with the carbons.
Okay. So can I see 5? That's one thing. We have to move the carbons and so 1, 2, 3, 5, 4. Then we go here. Let's move to forward.
Five.
CSL. अगले बार CSL.
Let me draw it. C5H10O. 1, 2, 3, 4. CHO is the first one. 1, 2, 3, 4. CHO is the second one. 1, 2, 3. CHO with 2 branches is the third one. Now CHO's position is not possible to change. 1, 2, 3, 4. And then see here.
And then one more cell CHO.
Sorry?
CHO at the end.
No, if you make it an end, so it's gonna be this one again. 1, 2, 3, 4. 4 is the total numbers.
Sit down and say.
आपने कितने बनाए? 4? What about you? 4.
I'm gonna always take the last one. I can't recall.
Okay, now this is the tricky one. If someone would be able to do it correctly, there is a cash prize waiting. C5H10O is an ester used in the food industry to give the products the flavor of apples, including methyl butanoate. How many structural isomers are there of C5H10O2 that are esters?
Sir, cash price.
Yeah, it's huge. It's big one.
More than a tuition fee.
Yeah, probably, surely.
That's
More than twice, I believe.
the, okay, so that. 1, 2, 3, 4.
That's the first one. Given.
I would suggest you to draw all possible structural isomers for this ester and then finally subtract this, the only one, and then you'll have the actual number. And I can give you an hint. I told you कि पहले हमेशा ये ester बनाया करें, in which put all carbon with oxygen. 1, 2, 3, 4. Yeah, this one. And then make the chain isomers.
Sir, 9. Come, let me do it.
No, the cash price is only, you only qualify for the cash price if you show me the structure of all 9, if the 9 is right answer, but the 9 is not right answer, by the way. But if it would have been, you have to show the structures of all 9 esters, then you qualify for that money.
I think all you know.
Honestly, I think it is 9 service.
What about it? Thanks to you. Eight. Speed. I don't know. Sorry. There's B seven. 6.
B,
B. No. 8 7. Take one is easy.
how many? Okay, let me draw it. Now I'm going to make a chain isomers. So here you go. I'm going to put 3 carbon in the chain and 1 in the branch. Again, I'm going to make a chain isomer. I'm going to put 2 carbon and 2 branches here. So these are the 3 chain isomers. Now let's shift them. So C double bond O, 1, 2, 3. There is also possible chain isomer for this. So I'm going to put them like this. Right? And there is also possible for this again.
But we can. Let's see.
3. So here it is 3. Okay, yeah, sorry. And then let's take it to the back side now.
6.
Ye ho gaya. 1, 2, 3, 4, 5. Then put 1 more on the back here. And then you can also make it a chain isomer for this.
So let's see 9.
This makes 8.
Right? So 1 more, I believe. Yeah, this one. This one can also change the position, na? If I put the carbon on this side.
So 9.
So HCOO and then 1. Now count 1, 2, 3, 4, 5, 6, 7, 8, 9. But you have to subtract 1. This one.
So 8 7.
Yeah, 8 is the right number.
Cash prize.
Is it clear?
Including, so including it's not 9 as it.
Yeah, if this one you includes, then it's a 9 number.
Including, so it's 9.
9. Okay, so that's all for this structural isomers. We'll start the stereoisomerism in the next class.
9.
Thank you.
So mistake.